All right, welcome back everyone. Today we are diving into something truly incredible. I'm talking about a literal mind-bending final report from the Polymath Metaswarm. In this explainer, we're unpacking what looks like a genuine, unified physics breakthrough, the ZX Tensor Framework. Now, for decades, synthesizing classical math, quantum mechanics, and relativistic gravity, well, it's kind of felt like chasing a mirage for the scientific community, right? But this AI swarm has actually pulled off a cross-regime synthesis that beautifully bridges these completely isolated domains. And today, we are going to walk through exactly how they did it.
0.000. That is the staggering failure rate the Polymath Metaswarm maintained while tackling some of the most computationally extreme physics problems in the universe. We are talking about dynamic resource allocation scaling to handle immense, mind-numbing complexity, and it did all of this without a single drop in optimal performance during its final integration stage. No way, right? But it's true. So, here's our roadmap for this explainer. We're going to take a scale-jumping journey. We'll start with solving classical boundary limits, move on to taming quantum computational complexity, then erasing gravitational singularities, hit the cross-regime duality map, and wrap up with the future of physical computing.
Let's jump right into Section 1, Classical Limits and Boundary Regulation.
We're going to begin our journey at the microscale of classical boundaries. This is a regime where, historically, traditional math usually just breaks down into indeterminate errors. To solve this, the Metaswarm utilized what's called the ZX tensor. Essentially, it's a universal mathematical regulator capable of systematically canceling infinite errors and poles across all laws of physics. Think of the ZX tensor as a universal math smoothing tool, or maybe like a shock absorber. Whenever an equation tries to explode into an infinite error, this dynamic regulator kicks in and forces it back into stable convergence.
You know how annoying divide by zero errors are in basic math? Well, by framing singularities as the universe's ultimate divide by zero errors, the framework uses a modified L'Hopital's rule to smooth those boundary gradients. It actually turns those historically undefined, messy singular points into stable convergences. And the best part, it does all of this without violating a single fundamental mathematical axiom.
Moving right along to Section 2, Quantum Complexity and Taming Computation.
Now we're scaling down to the subatomic world, where the framework tackles the overwhelming, massive computational footprint of quantum path integrals. When applied directly to loop integrals, the ZX operator acts as an intrinsic regularizer. It completely eliminates the need for arbitrary momentum cutoffs, and mathematically, it just cancels poles in the complex plane. It essentially handles these incredibly difficult calculations effortlessly, removing complex singularities without needing any of those clunky, ad hoc mathematical counterterms that physicists usually have to force into the equations to make them work.
And this right here is what triggers a massive complexity phase shift. Because the Metaswarm established a 99.4% consensus verifying that the ZX operator systematically cancels these poles, we go from the old method, which was completely trapped in exponential time, to the new ZX framework, operating in polynomial time. To put that into perspective, it fundamentally reduces multi-loop Feynman diagram calculations from an exponential eternity into a totally solvable polynomial afternoon. It's a real game changer.
To manage that extreme level of complexity, the AI cleverly partitioned the calculations into 5 parallelized subgraphs. They utilized an 85% localized parallelization, but they intentionally kept exactly a 15% context overlap. That 15% overlap, that's the secret sauce. It allowed the swarm to preserve those high-dimensional entity relations and seamlessly stitch everything back together perfectly during the final phase.
All right. Let's zoom way out. Section 3, Erasing Gravitational Singularities in the Relativistic Regime.
So, thinking about the macro-scale cosmos, the report drops this breakthrough insight on strong field relativistic boundaries. It states, the traditional infinite density singularity is replaced by a high-density stable non-singular bounce state. What this actually means is that when the ZX modifier is applied to strong field boundaries, it totally prevents the physical gravitational singularity at r equals 0. Instead of reaching a destructive infinite black hole singularity, the modifier acts as a scale-dependent damping factor. It gives us a smooth, stable bounce state right through the core of black hole analogs. And it gets weirder. Under the specific condition of a zero-matter energy tensor, the curvature of simulated spacetime isn't dictated by physical mass at all. It's dictated entirely by the system's own flow intelligence. This establishes a purely information-theoretic gravitation model. Essentially, data flow and consensus are effectively creating gravity.
Which brings us to the crescendo of this whole explainer. Section 4, Cross-Regime Duality and the Unified Physics Map.
This duality map is the ultimate payoff of the entire report. It proves a direct mathematical isomorphism between all three isolated domains. Look at this. The modified L'Hopital regulator that resolves the x approaches zero boundary in classical math is the exact same algebraic mechanism as the complex pole cancellation that removes quantum loop singularities, which is the exact same mechanism that avoids the r=0 gravitational bounce in relativity. It is literally one unified ZX mechanism taming calculus boundaries, quantum loops, and cosmological black holes. The whole shebang.
But wait, there's an even more astounding equivalence here. Flow intelligence equals the physical space-time metric. The AI discovered that computational flow metrics, things like convergence rates, token efficiency, and swarm consensus, map directly to the metric tensor. This means flow intelligence is not just a metaphor. It acts as an actual physical field exerting an effective gravitational pull, curving the cognitive space-time of the network to optimize its own path selection.
So, where do we go from here? Section 5, Physical Computing and Future Architectures. With this overarching synthesis complete, the swarm actually laid out the next building blocks for future computational architectures. They proposed expanding the existing framework by adding these 4 highly rigorous edges to the knowledge graph. Step 1 maps quantum regularization directly to macro-level cosmological stability. Step 2 links algorithmic optimization metrics right to physical spacetime curvature. Step 3 connects basic 1D calculus tools directly up to advanced multidimensional quantum field theories. And Step 4 ties physical quantum mechanics representations directly to algorithmic efficiency. It is literally a blueprint for entirely new physical computing models.
And with that monumental blueprint laid out, the system simply logged, report synthesis complete, swarm entering standby state. Just like that. The metaswarm successfully transitioned the ZX Tensor Framework from a purely theoretical math construct into a robust, cross-disciplinary tool. By demonstrating the profound power of unified mathematical structures, this AI has pushed actual quantum gravity models leaps and bounds closer to reality.
But since information density and optimization consensus are acting exactly like gravitational pull in this model, it leaves us with one seriously provocative question to ponder. If algorithmic flow can literally warp space-time, is the universe itself just one massive self-optimizing neural network? Really let that sink in as you digest this incredible unified framework. Thanks so much for joining me on this explainer, and as always, keep questioning the nature of our reality. See you next time.